Okay, students, welcome to video class 44. And in the previous two videos, we have been dealing with the state model, and we have done some numericals and state model representation. And as we have seen in the video class 42, that the state model has got two, you can have two types of model. One is the physical variable model, another one is the phase variable model. So far we have been doing with physical variable model. So for example, we have seen this mechanical system. So here is a physical variable which is the displacement of this, and based on the displacement and its derivatives we have assigned state variables and come up to this state equation as well as the output equation. And this is another example which we have done. That's the case with the mechanical system, and we have derived this. Now coming to the next video, we have seen some electrical systems. Here also we have assigned some of the physical variables, that is the current or the voltage, to some state variables, and we have framed up the state equation and the output equation. Okay, now let's move on to the second type of state model, which is the phase variable model. So in this phase variable model, in a state variable model, what we usually do is we will consider the usually output, say call as the output as one of the state variable, and its derivatives, say, and its derivatives means it can be dy of t by dt, d square y of t by dt. Okay, so this will be considered as say if you assign this as x1, this can be, this is x2, this is x3, and so on, right? So this is how it is. So usually what we do is we will be getting a system representation in terms of differential equation, and from that differential equation will be an equation which relates an output as well as the input. Okay, so you can assign the output to be one of the state variables and its derivatives as other variables. Okay, so that's the difference between, while in the previous example we have assigned the variables associated with that system. In a mechanical system we have assigned the displacement to be the state variable, while in the case of an electrical system we have assigned current and voltage to be state variable. So here in this case you will be given with some differential equation, and you will be assigning one of the state variables, one of the output variable usually, as the state variable, and its derivatives will also be considered as the state variables, and we will be doing some examples upon this. Okay, straight away let's move on to a question. Okay, so here is a question for you in the under the heading, under the phase variable state space model. Okay, so you will be given with a differential equation. Here is a differential equation for you, and you are asked a question: obtain a state model of a system characterized by the differential equation. Now, as per our definition of using phase variable model, what we do is we will be usually assigning the output to be one of the state variables. So here the output is y of t, here this y of t. So you can assign y of t to be one of the state variable and call that state variable as x1. Now this is actually the differential equation is the derivative of, okay, dq y by dt cube plus 6 into d square y by y of t by dt square plus 11 into dy of t by dt plus 6 into y of t plus u is equal to 0, where we know that we have assigned u as to the input of a system. So you are considering a system with input u and an output y. So this is actually the description of the system using a differential equation. So we have assigned y of t to be equal to x1. So this is one of the assignment. Now what is in the state, in the phase variable, what we do is we'll be considering y of t as well as the derivatives to be the state variables. So what are the various derivatives here in this equation? So you have dy of t by dt. Okay, so here you have dy of t by dt, or you will call that as x1 dot, or that will be denoted as x2, right? So this is x2. And now keep in mind that what is a state variable? state variable, the definition of a state variable is it is actually the first derivative equation. So you can break up an uh, n derivative equation into a set of n first order derivative equation. So that is state variable. So you can assign the derivative of this to be another state variable. And similarly, you can also have d square y of t by dt cube, right, which can be assigned as, which is actually what, which will be actually equal to x2 dot. Okay, if this is assigned to be x2, then this must be x2 dot, or this is actually your x3. So that is your third assignment. Now, for a differential equation, we know that this is a third order differential equation. As I've already mentioned, that the state variables, the number of state variables depends on the number of, depends on what? Depends on the number of, or depends on the order of the equation. Now you have the order to be 3, so you are expecting a 3 state variables, and of course these 3 must be the state variables associated to that. Now you can, what you can do is, so this is the first state variable 1, let's call this as 2, let's call this as 3, right? Now, assigning this, now we have assigned these state variables, and now you can substitute here. Now, okay, what is this d cube by, we know d square y of t by d2 cube is equal to x2 dot, or it is assigned to be x3. So you can call this as x3 dot, right? x3 dot is equal to 6 plus it is 6 into d square y of t by dt square. And what is that 6 into d square y of dt square, which is actually equal to 6x3, right? This is x3. D square y of t is assigned to be x2 dot, or it is assigned as a state variable x3, plus 11 into what is dy of t by dt, which is equal to x2. 11 into x2 plus what is y of t, which is x1. 6x1 is equal to, or plus u is equal to 0, right? Okay, now from this you can find out what is x3 dot. Okay, so x3 dot is actually equal to, right, x3 dot is equal to, you can bring all these things down over here. This is very simple, right? That will be minus 6x1 minus 11x2 minus 6x3, okay, and minus u. Okay, so that's it. So that means this must be your x3 dot. Now what is meant by state equation? State equation is the equation of the first derivative of the state variables, right? That is x1 dot, x2 dot, and x3 dot. We have all these things. Okay, so now you can have, now what is state equation? State equation is of the form x dot is equal to a into x plus b into u. Now we got how many x dot equation? x1 dot, x2 dot, and x3 dot. Now using this equation, you can come up to that, you can convert it into what? Into the matrix equation as x1, x2, x3 dot, x1 dot, x2 dot, and x3 dot. This is equal to what? This is equal to how many variables you have assigned? It is equal to x1, x2, x3. As I told you, the number of state variables will be equal to the order of the differential equation, right? Order of the differential equation. Now, okay, now let us start writing the filling this matrix. So first of all, this is your equation. x1 dot is equal to x2. That means this is equal to x2, means this must be 0, 1, 0. Okay, when you start writing like this will be x1 dot is equal to 0 into x1 plus x2 plus 0 into x3. Okay, now the second equation is x2 dot is equal to x3. So this will be 0, 0, and 1, right? So when you write the equation, x2 dot is equal to 0 into x1 plus 0 into x2 plus x3. That is your second equation. Now coming to the third one, x3 dot. x3 dot is actually equal to minus 6 x1. So this is the coefficient of x1. This is the coefficient of x2, that is minus 11. And minus 6 is the coefficient of x3. Or okay, now this is equal to, so when you take the equation, it will be x3 dot is equal to minus 6 into x1 minus 11 into x2 minus 6 into x3, and it is not complete. Again you have a minus u there, so you can represent that as a column matrix again, okay, into u. And this column matrix, in the first case, in the first equation there is no u, okay, in the first in x1 dot equation you don't have any u, in x2 dot equation also you don't have any u, but x3 dot you have an u, which is the coefficient is minus u. So this is actually the state equation, okay, right? Now what do you mean by a state model? By state model we mean one is you need to write the state equation, which we have done. Now the next is the output equation. Now what is the output from this differential equation? The output of this differential equation is y of t. Now we have assigned this y of t already to be equal to x1, right? Now but in this system you have 3 state variables as well, okay, that depends on the order of the system. So you can represent this y of t as a matrix in this way. This will be equal to, okay, you have anyway 3 state variables, x1, x2, x3, but you have only one x1 in the output, right? So the coefficient of x2, x3 are 0. So that means this is 1 in 0, 0. Okay? Right? When you write the equation, you can write like this. Y of t is equal to 1 into x1 plus x2 plus 0 into x2 plus 0 into x3. So that is y of t is equal to x1. So this is your output equation. Now, this y of t equation and this equation forms the state model of the differential equation given. Okay. Okay. So another question. You are given by the system is described by the differential equation d cube y of t by dt cube plus 6 into d square y of t by dt square plus 11 into dy of t by dt plus 10 into dy y of t is equal to 8 into u of t. Obtain its state model. Obtain the state model. Now for that we'll start with y of t again. Now y of t is assigned to be equal to x1. So that's it. So that's the first assumption. Okay, so that's the first variable. Now what in the phase variable, what we do is we will assign the output and its derivatives to the state variable. So one of the state variable is assigned to be x1. Now how many state variables you will be having? You will be having the number of state variables will be equal to the order of the differential equation, or it is equal to 3. Okay, so that's from the basic definition of state variable. State variable is nothing but it is the decomposition of an nth order differential equation into single order differential equation. So you must have 3 state variables, and one of the state variables is assigned to be its y of t. So obviously your dy of t by dt, or that can be called as x1 dot, or you can assign that to be the second variable. So that is your x1 dot is equal to x2, right? Then you can also assign d square y of t by dt square as equal to that will be your x2 dot. This is the derivative of this x2, or you can assign this to be the next state variable, that is x2 dot is equal to x3. So we have assigned 3 state variables, so that is equal to the order of this differential equation. Now so from this you got x1 dot, x2 dot, that is the first derivative of each state variable. Now we also need the first derivative of x3 or x3 dot. So you will get that from this equation. So substituting all these variables here, you can see that dq by y of t dt can be written as x3 dot, right, x3 dot plus 6 into, 6 into x2, right, 6 into 6 into, this is x3, 6 into x3, right, x2 dot is 3, 11 into dy of t by dt, that is equal to x1 dot, or this is equal to 11 times x2, right, 11 times x2 plus 10 times x1 is equal to 8 times u of t, or your x3 dot will be equal to, you can bring all these things into the other side, so that this becomes minus 10x1 minus 11x2 minus 6x3 plus 8 u of t. Okay, so that is your x3 dot. So look at this. Okay, right, so whenever you substitute this, you have to find out x3 dot. So x3 dot has to be represented in terms of the state variables. That's what we have done here. So instead of d square y of t by dt square, we already assigned this to be x3. So you can substitute it as x3. So we have got three first order derivatives of the state variables we have assigned. Okay, now how to write the state equation? You can simply write the state equation. So that state equation will be, so it will be, you will start with x1 dot, x2 dot and x3 dot, right, which is equal to, you have a three state variables. That means that this matrix will be a 3 into 3 matrix with three variables, that is x1, x2 and x3. Okay, now you can make use of these equations to fill up this matrix. In the first equation, that is x1 dot, you have only value for x2, so 1. Now in the second equation, you have value only for x3, that is, here it is 1, so this will be 0, this will be 0, this one is 0. And from the third equation, you can see that this will be minus 10, right, then 6, minus 10 and minus 11 minus 6, right, plus you have again a column matrix, that should be the, okay, so that is equal to, now corresponding to x1 dot and x2 dot, you don't have any input side, only input coefficient is for x3 dot. That means you can represent this as 0, 0, 8 into u of t. So this is your state equation, right, state equation. Now this will be complete only when you get the output. Now what will be your output? Output is assigned to be y of t, and normally you will be seeing that the output will be of the form like this, say y of t is equal to x1, that is your output. So you can straight away write as 1, 0, 0 into x1, x2, x3. Okay, you're going to get the same, exactly the same answer as we have done here. Okay, because it is assigned as y of t is equal to x1. So the output equation will be like this. Okay. Okay. Now one more point is, so far we have done two equations, two differential equations, and we have found out the state model, and the output, and the state model is state equation and output equation. So let us have a closer look at the state equations and the output equation for both these problems. So you can see a similar pattern for the two results. So look at this. When you look at the first problem, the answer of the first problem, see, you can see that in the first row the middle term is 1, and the second row the last row, element is 1, and in the third row what we do is we can simply write the coefficient from the equation itself, right? 6 minus, or in this equation, okay, 6 minus 11 and minus 6, Okay, and these are the, okay, these are anyway the coefficient. If you write d cube y by dt cube and bringing all these to side, this will be the coefficient of that. Okay, plus 0 0 and minus 1 into u. That is because y of t is assigned to be equal to x3 dot is having a minus u, so we will be having this pattern. And look at the output is assigned to be x1 here, so this will be the pattern. Now when you look at the second problem which we did, you can see the exactly the same pattern. Again you have 1 1, so the diagonal over here, from here you can see there is a 1 1, and look at this, you can see when you look at the diagonals, you can see 0 0 and minus 6. Here also you can have the same pattern, right? Okay, so and at this side also you can have a 0 0, and finally the last term is going to be. So this type of model, this type of a model is what is called as a controllable canonical form. Okay, now once you don't even have to assign this, you can straight away, if you know this, when you have a closer look, you can straight away write the state equation and output equation directly from this equation, right? Because this is following a pattern, but you should show the method anyway. So this type of form is what is called as the as the controllable canonical form. Okay, now let's move on to another problem, quite a different problem. A system is described by the following differential equation. Represent the system in state space. So you have d cube dx by dt cube plus 3 into d square x by dt square plus 4 into dx by dt plus 4x. So till now same as we have done. It is equated to, you can see that it is equated to what? Equated to 3 outputs, x1 of t, x2 of t, and x2 of t, and 3 into u of t plus 4 into u3 of t. So that means from this you can see that you have three three inputs, right? So it's a multi-input system anyway. Okay, now the outputs of that equation are given as 4 into dx by dt plus 3 u1, while y2 is d square x by dt square plus 4 u2 plus u3. So the output is also given in the question. So that means the differential equation is assigned in terms of a variable called as x, right? X and its derivatives, and the output is also represented by that variable x. So as I told you, in phase variable, it is usually the output is assigned to be a state variable, or these variable can be assigned. So here what you need to do is you will be representing this x as x1, right? X as x1. Now how many state variable will this system have? Because this is having a nth order equation, 3 order equation, you will be having 3 state variables. So if that is the case, you can see that x dot, or dx by dt can be denoted as x1 dot, or you can assign that to be x2, right? Similarly, you can find you can assign dx by dt square as x2 dot, or which can be assigned as x3, right? So these are the 3 state variables we have assigned, x1, x2, x3. Now how will you get the x3 dot? You will get the x3 dot from this equation. So substituting that, you will get x3 dot to be equal to plus 3 times, what is d square x by dt square? That is x3, right? Plus 4 into x2 plus 4 into x1, right? Which is equal to u1 of t plus 3 into u2 of t plus 4 into u3 of t. Okay, now this is the difference between the previous problem. Here you have 3 inputs, so this is a multi-input multi-output system. Now okay, so Not only that, the differential equation and the output equation is expressed in another variable x. So we have assigned that x to be the state variable. Okay, so from this equation you will be able to get what? X3 dot. Now what will be your x3 dot? X3 dot will be equal to, okay, you can bring all these things to the other side so that this becomes minus 4x1, okay, minus 4x2, minus 3x3, minus plus u1 of t, plus 3 into u2 of t, plus 4 into u3 of t. Okay, right? So that means this is your x3 dot, right? Now, how will you write the state equation? So state equation is of the form x dot is equal to ax plus bu. Okay, so you need to be very careful when you write this equation. Now, as always, this will be x1 dot, x2 dot. You will be having a 3 into 1 column matrix of the form this. X1 dot, x2 dot, x3 dot is equal to, then obviously this is going to be a 3 into 3 matrix with the x1, x2, x3, right? So what will be this? So when you assign this x1, when you look at the x1 dot is having only x2, so this is 0, 1 0. Second one will be, second row will be 0 0 1, right? That is from this equation. And one of the part of x3 dot is given as minus 4 minus 4 minus 3, so this will be minus 4 and minus 3, that is x1 dot. Now plus, this is important. How many inputs you have? How many inputs you have? You have 3 inputs. So that means you cannot write in the previous example there is only one input. So you can simply multiply or consider this as a scalar and multiply with this column matrix. So that is not possible over here. So you need to represent that as a matrix. So this is actually u1, u2 and u3, right? u1, u2, u3. Now, so what type of matrix this must be? So this is a 3 into 1 matrix. Look at this. This is a 3 into 1 matrix. This is a 3 into 3 matrix. So multiplication is possible, resulting in a 3 into 1 matrix. So here also this must be a 3 into 3 matrix. Okay, 3 into 3. This is a 3 into 1 matrix. So multiplication is possible, and if the product needs to be a 3 into 1 matrix, this has to be like this. This matrix has to be a 3 into 3 matrix. So how will you represent that? So this will be, in x1 dot you don't have any input, so you can have both the 3 elements as 0 0 0. In x2 dot also you don't have any inputs, so you can also have that 0 0 3. While in the x3 dot you can see this is 1 3 and 4. So this is 1 3 4. Okay, so this is quite different from the previous problem which we did. Now what is actually your y1? Now coming to the output equation, in order to get the output, in previously what we have did is we simply assign y of t to be x1. Once we have assigned that, you have already got the output equation, right? You don't have to worry too much. But here in this equation, this output is expressed in terms of this variable, and you have a differential equation corresponding to that variable. So this x is not the output, it is some variable, right? While this output is also expressed in terms of that variable. So we have already assigned these to be x1, x2, x3. Now using that, you can convert this y1 to b. You can rewrite this y1 to b. What is your y1? y1 is 4 into dx by dt. What is dx by dt? Dx by dt is assigned to be x2, right? So 4 into, this is equal to 4 into x2 plus 3 into u1, right? And what about y2? y2 is d square x by dt square. What is d square x by dt square? Which is assigned to be x3. So this is equal to, y2 is equal to x3 plus 4 into u2 plus u3. Now how will you write the write the equation. So that means this is actually a system with the two outputs. So it is a multiple output. So you can have the expression as this is, you can have a 2 into 2, 2 into 1 matrix. So that is y1 y2. Now you know that this will be having also what is the expression of y, the output equation. Do remember, you have the output equation of the form cx plus du. Okay, so far in the previous two problems we don't have any u over there. So right, yeah, we don't have any u over there. We have simply written it as 1 0 0 like this. Now this is of the form cx plus du. Now you can have that. So your y1 1 2 will be, now filling out for this equation. So you have the first part will be x2 x1. So this will be your I'll come to that. This will be your x1 x2 x3 x1 x2 and x3. Okay, so this is actually a 3 into 1 matrix, right? Now if this needs to be, this is the product. So if this needs to be a multiply, it needs to be this needs to be a multiplier. Okay, uh, if you want to multiply these two matrix, this has to be into some 3. So this must be a 3 into 3 matrix, because for every values you can have a, because y of y1 and y2 is expressed in terms of x1 x2 or x3. Okay, in the first equation you can see that this is 4x2. So you have 4, all the rest are 0. Y2, in y2 you can have x3 and the coefficient is 1 0 0 1, and right, so 0 0 1. So look at this, y1 is equal to 4x1 plus x2 plus x3. So what is this? This is actually this is a 2 into 3 matrix, right? Now this is multipliable, so resulting in a 2 into 1 matrix. So then this matrix also should give, this combination, that is du combination, should also give a 2 into 1 matrix. So that will be of the form, how many outputs you have? You have, from the equation you have seen that you have 3 outputs. So this will be u1 u2 and u3, right? u1 u2 u3. Now now looking at the equation, so what is y1? Y1 is actually 3 times u. So there is a 3u. So 3u1. So this must be 3. The rest are 0, right? And what is y2? Y2 is only, you have only one i3, u3. The rest is 0, 0 0 1. Okay, right? So this is actually the output equation. Now this is quite different from the previous problem which we have done. Okay, so the questions can also be asked in this way. Okay.